What if I told you the secret to a cleaner, more efficient fuel isn't some new chemical or a fancy miracle crop, but a sound you can't even hear? Yeah, today we're going to dive into some incredible research that shows how a simple vibration could literally change the game.
I mean, just listen to this. This quote comes straight from the research paper, and it sounds like pure science fiction, right? We're talking about the temperature of the sun and the pressure of the deepest parts of the ocean, all happening inside a bubble so tiny you can't even see it. This is the mind-blowing power we're going to unpack today, and it all comes from the science of ultrasound.
And the person leading this charge, that would be Dr. Mahmoud Karimi. He's a real expert in sustainable energy and advanced biofuels, with a background that includes places like Stanford and UC Davis. His whole focus is on finding scalable, efficient ways to get us to renewable fuels. So yeah, we're in very, very good hands here.
All right, so to really get why this ultrasound tech is such a big deal, we first need to understand the problem it's trying to solve. Why is turning a plant into fuel so ridiculously hard to begin with?
Look, we all know we need clean alternatives to fossil fuels, and fast. Ethanol, which we can make from all sorts of plants, and even agricultural waste, is one of our best shots at a renewable liquid fuel. It's a huge deal for energy independence and for cutting down greenhouse gases. But here's the catch. Plants are built to survive. They're tough. That lignocellulose you find in wood and straw, it's basically nature's version of reinforced concrete. And the starch in corn and grains, it's locked away in these super dense little granules. Both of these structures are like a fortress, and they block the enzymes we need to get in there and release the sugars to make fuel.
So, to get past these defenses, the industry uses a process called pretreatment. You can think of it as bringing in a demolition crew. The problem is that demolition crew is often the most expensive, slowest, and least efficient part of the whole operation, usually relying on harsh chemicals or just a ton of energy.
Okay, but this is where the story gets really, really cool. We're going to zoom all the way in, down to the microscopic level, and look at this science called sonochemistry and the unbelievable power hiding inside those tiny bubbles we mentioned.
It all comes down to a phenomenon called acoustic cavitation. Here's how it works. You take a liquid and you blast it with high-intensity ultrasound. That's sound waves way above what we can hear. This creates these tiny, microscopic bubbles. But these aren't your typical bubbles. They grow, and then they violently, and I mean violently, implode. And that collapse, that's where the magic happens.
You can think of it as a three-step process. First up, nucleation. A tiny bubble is born. Then growth. The sound waves pump it up bigger and bigger, like a balloon. And then the grand finale, implosion. The bubble collapses in on itself with incredible force, releasing a huge, focused burst of energy. Now get this, that one little implosion unleashes two different kinds of power at the same time. You've got the physical effects. We're talking microjets of liquid and shock waves that act like microscopic pressure washers, just physically blasting stuff apart. And then you've got the chemical effects. The insane heat and pressure from the collapse create these super reactive things called free radicals, which can kickstart all sorts of chemical reactions. So, we have this incredible force. Now what do we do with it? Well, let's start by pointing it at lignocellulose. You remember, nature's reinforced concrete? Okay, so that concrete is really made of three things. Cellulose is the prize. That's where the sugar is. But it's protected by a barrier of hemicellulose, and the whole thing is held together with lignin, which is like a super strong structural glue. To get the goods, you have to break through all that first. And this is where those little pressure washers we just talked about come into play. The physical shock waves from the bubble collapse just hammer away at that structure. They erode and crack the lignin and hemicellulose. It's like sandblasting at a microscopic level. And what this does is massively increase the surface area that the enzymes can finally get to. So the big question is, does it work? Oh yeah, it works. Big time. Just look at this data from sugarcane bagasse. A standard chemical treatment gets you a decent amount of glucose, but you add ultrasound into the mix, the yield absolutely skyrockets, hitting over 90% of the theoretical maximum. That's a massive improvement. But this tech isn't just a one-trick pony for tough, woody stuff. Turns out, it's also incredibly good at breaking down starch.
Now, starch is a different kind of challenge. Its energy is stored in these really tightly packed crystalline granules. It's the same basic problem as before, just a different kind of fortress. That structure shields the good stuff, the sugars, and makes them hard for the enzymes to get to.
And the effect of ultrasound on starch is just wow. It can completely shatter these granules. reducing the particle size of cornstarch by up to 20 times. 20. Just imagine taking a huge boulder and smashing it into a pile of pebbles. You've just created a ton of new surface area for the enzymes to attack.
So what does all that shattering actually do? Well, it has a direct payoff. It speeds up something called gelatinization, which basically just makes the starch more available. This lets the enzymes get in there and release those sugars way faster. We're talking a fraction of the time it would normally take.
Okay, so we've been deep in the weeds at the micro level. Let's pull back now and look at the big picture. What does this all mean in the real world?
So you might be thinking, don't we already have ways to do this? And yes, we do. But look at the trade-offs. Methods like acid hydrolysis work, sure, but they cause corrosion and can create nasty byproducts. Steam explosion is cheaper, but it can create other compounds that actually slow down the next step. The huge advantage of ultrasound is that it physically rips the cells apart without creating those inhibitors. It's just a cleaner process.
So let's boil it all down. What's the real payoff here? It's simple. You get higher yields of sugar and ethanol, you get it done in way less time, you don't need to use as many harsh chemicals, and the whole thing could be more energy efficient than other methods. It's pretty much a win-win-win.
When you get right down to it, what we're looking at is just a brilliant example of using physics to supercharge biology. This science of sonochemistry is giving us a cleaner, faster, and just plain more efficient way to create the sustainable fuels that our planet desperately needs.
So I guess I'll just leave you with this one thought to chew on. Could the simple, powerful, and invisible sound of a collapsing bubble really be a key to powering our future? It's a pretty incredible thing to think about.